Hey everyone, and welcome back to Decoded Influence, where we take those deep dives into the fascinating ideas shaping our world.
That's right.
For this deep dive, you, our listeners, have given us a really interesting challenge. You want us to explore the connections between, get this, light, time, and memory.
Yeah, three pretty big concepts, right?
It might seem kind of strange at first, but once you start thinking about it, you realize how deeply these ideas are intertwined. And you know what? Our source material, it spans like everything from, hardcore physics and astronomy to philosophy, art, and even like the latest tech innovations.
Oh, absolutely. We've got a lot to unpack here, from the way starlight lets us peer into the past to how our own brains use light to form and access memory.
Exactly. And then there's like, all the ways we use light to create lasting records, photographs, movies, even storing data in DNA. It's mind-blowing.
So, our mission today is to really untangle these ideas for you. We're going to shine a light, so to speak, on the surprising ways light acts as both a recorder of the universe's history and this key element in how we as humans remember and connect with our own past.
All right, so let's jump right in. Let's
Yeah.
start with something I find just mind-boggling: starlight.
Right.
When we look up at the night sky, we're not seeing stars as they are right now. We're actually looking back in time.
Yeah. Because, light travels at a certain speed, a really, really fast speed, but it's still finite. And the distances in space, they're just, well, astronomical.
So, for example, light from Proxima Centauri, our closest star neighbor, it takes over 4 years to reach us.
Right. So when we look at Proxima Centauri, we're seeing it as it was over 4 years ago. We're literally looking into the
Oh,
past.
crazy. And what about like really distant galaxies like Andromeda?
Well, Andromeda, that light has been traveling for about 2.5 million years. Imagine that we're seeing a snapshot of that galaxy from a time when, well, our early human ancestors were just figuring out how to walk on two legs.
It's like having a time machine built into our eyes. And telescopes like the James Webb Space Telescope, it's like they're cranking up the power on that time machine.
Yeah. James Webb is letting us see galaxies as they were, just a few 100 million years after the Big Bang. It's helping us piece together the very early history of the universe.
It's incredible. And it's not just about, seeing into the past. It's also about what that light can tell us, like the information it carries.
You're talking about redshift, right?
Yeah, exactly.
So as the universe expands, galaxies are moving away from each other, and this movement stretches the light waves coming from those galaxies.
Kind of like how a siren sounds lower pitched as an ambulance moves away from you.
Exactly. So this stretching of light waves shifts them towards the red end of the spectrum. That's why it's called redshift. And the amount of redshift, it tells us how fast a galaxy is moving away, which then tells us how far away it is and how long that light has been traveling.
So it's like the farther away a galaxy is, the more red shifted its light is.
Right. And there's this really cool relationship called Hubble's law that connects this redshift to the speed at which galaxies are receding.
And this Hubble's law, it's like the cornerstone of our understanding of the expanding universe, right?
It is. And it gives us a way to map out the timeline of the cosmos, using the light from those distant galaxies as our guide.
It's just amazing. And then there's the cosmic microwave background radiation, or the CMB, like a whisper from the very beginning of the universe.
The CMB is, well, it's mind-blowing. It's the faint afterglow of the Big Bang, the earliest light that could travel freely through the universe after, things cooled down enough.
And this light, we can detect it even today.
Oh, yeah. It's everywhere. This faint microwave radiation coming from every direction in space. And the crazy thing is, it's not perfectly uniform. There are these tiny, tiny temperature fluctuations in the CMB.
So what do those fluctuations tell us?
They represent the seeds of the large-scale structures we see in the universe today. Galaxies, clusters of galaxies, the whole cosmic web. It's like a baby picture of the universe, a snapshot of its very early state.
Okay, so light from the cosmos is like this incredible time capsule, carrying information about the past from billions of years ago. But light has also been crucial in how we humans have tried to capture and preserve our own past. Right?
Oh, yeah, for sure. The invention of photography, that was a game changer.
Suddenly, we could use light to create lasting images of moments in time, to freeze those memories in place.
The early photographic processes, like the daguerreotype, they were pretty intricate. But the basic idea was that light would actually alter the chemicals on a treated surface, leaving behind a permanent image.
And then, things really took off. Film photography, color photography, instant photography. But even today, with our digital cameras and smartphones, it all comes down to capturing light.
Right. Digital sensors convert light into electrical signals, which are then turned into digital data, those ones and zeros. But the core principle is the same. It's about using light to create a record of what we see.
And it's not just still images, right? We use light to store all sorts of information, like
Hmm.
on CDs, DVDs, Blu-ray discs.
Optical storage technology, it's all about using lasers, those highly focused beams of light, to read and write data onto the surface of a disk.
Right, like those tiny pits and bumps on a CD, they reflect the laser light differently, and that's how the data is encoded.
And then you've got all these new, even crazier technologies on the horizon for storing even more information using light.
Like holographic storage, where you can store data in 3 dimensions within a crystal or something like that.
Right, or encoding data in DNA. I mean, that's some next level stuff.
Like Project Silica, Microsoft's project for archiving data on quartz glass, and the Archmission Foundation, which is all about creating these backups of human knowledge that could survive like almost anything.
They're using light to try to preserve our collective memory for, well, practically forever.
It's almost poetic using the same force that lets us see across billions of light years to try and safeguard our own memories and knowledge.
Yeah, it's like this deep human impulse to push back against time, to hold on to things that would otherwise fade away.
And then we have the internet, which feels like this giant, ever-growing memory bank. And it's all powered by light, too, right?
Yeah, fiber optic cables, that's the backbone of the internet. They transmit data as pulses of light incredibly fast.
So all those emails, videos, websites, it's all light zipping around the globe.
It is. But even at the speed of light, there are delays when we try to communicate over really vast distances. Like, think about trying to have a real-time conversation with someone on Mars. It's not quite possible because of that time lag.
Makes you realize just how big the universe is. But okay, let's shift gears a little. Light isn't just this physical thing, right? It's also deeply embedded in our language, our culture, our philosophy.
Absolutely. When we talk about understanding something, we often use metaphors of light.
Yeah, like shedding light on a problem or having an illuminating insight.
Exactly. And this link between light and knowledge, it goes back centuries. Think about the Enlightenment. That whole movement was about using reason to bring light to the world, to dispel ignorance and superstition.
And then there are all the rituals and memorials across different cultures that use light to connect us with the past.
So many examples. Like the eternal flames that burn at memorials, the John F. Kennedy eternal flame, the one at Yad Vashem, they symbolize enduring remembrance, the idea that the memory never goes out.
Or think about all those lantern festivals around the world.
Yeah.
Japan's Obon, Diwali in India, Thailand's Loy Krathong.
They all use light in these beautiful, symbolic ways to honor the past, to remember ancestors, to bridge that gap between the living and the dead.
Even the tribute in light in New York City. Those beams of light shooting up into the sky every year on the anniversary of 9/11.
Yeah, using light to mark absence, to remember a collective trauma, it's powerful stuff.
It's interesting though, isn't it? Light itself is so fleeting. It flickers, it can be blocked, stars eventually burn out.
Right.
Yet we use it to symbolize something lasting, the enduring power of memory.
Yeah, there's a real paradox there. And it's reflected in the way our own memories fade over time, or how even the most durable storage mediums can eventually degrade.
Old photographs lose their clarity, data gets corrupted. It's a reminder that memory, in all its forms, is ultimately fragile.
Absolutely. And this brings us to how our own brains use light to form memories.
Well, vision, our primary sense for forming memories, it all depends on light.
Right. Light enters our eyes, and it's processed by those incredibly complex neural networks in our brains. It's how we create the images we see and later remember.
And studies on people who've lost their sight, they show just how crucial vision is for memory. The absence of light input, it really impacts how they form and retrieve memories.
That's right. And then, there's this whole other side to the story, the way we're constantly bombarded with artificial light in our modern world.
Yeah, especially with screens, phones, computers, TVs. It's like we're always bathed in this artificial light. How's that impacting our brains?
It's a good question, and researchers are still trying to figure it all out. But there's this idea of digital amnesia, the idea that because we rely so much on our devices to store information, we may actually be less likely to remember things ourselves.
Kind of scary if you think about it.
It is. It raises questions about what happens to our own cognitive abilities when we offload so much of our memory to external systems.
Speaking of technology, our sources hinted at some pretty wild possibilities for the future. Things like optical AI and interstellar time capsules.
Oh, yeah, the intersection of light, time, and memory is only going to get more complex and mind bending.
This idea of optical AI, where they're using light to create neural networks that could potentially, like, simulate or even enhance human memory.
Yeah, imagine interacting with holographic projections of historical figures, or even being able to relive past experiences in some super realistic way.
It's like science fiction becoming reality.
And then there's the idea of sending messages encoded in light out to other stars.
Yeah, like a cosmic time capsule.
Projects like Breakthrough Starshot, they're aiming to send these tiny probes traveling at a significant fraction of the speed of light to other star systems. And the idea is to include information about us, about our history and culture on those probes.
It's like trying to create a backup of humanity on a cosmic scale.
Exactly. But as these technologies become more powerful, it's important to think about the ethical
Oh,
implications.
yeah, for sure. Like, who controls access to these memories? What happens if they can be altered or erased? What about privacy in a world where our memories might be more accessible or even integrated with technology?
These are all big questions we need to be grappling with right now.
Absolutely. Okay, let's dive a little deeper into some of these emerging memory technologies like DNA data storage. I mean, that's just wild.
So, DNA is incredibly good at storing information. I mean, it's how life on Earth has been storing genetic information for billions of years.
Right. And now we're figuring out how to encode digital data into synthetic DNA strands.
And the storage capacity is huge.
Yeah.
You could potentially fit an entire library's worth of data in a tiny speck of DNA. Plus, DNA is incredibly durable. Under the right conditions, it can last for like hundreds of thousands of years.
So it's like the ultimate archive. But it raises some really big questions about curation, right? Like, how do you organize and access information stored in DNA over such long timescales?
Yeah, and what about the ethical considerations? Who decides what gets stored and who has access?
Big stuff to think about.
Yeah.
Then there's holographic memory, the idea of creating these three-dimensional recordings of events.
Imagine being able to step into a holographic recreation of a historical event, to experience it almost as if you were there.
Like a fully immersive history lesson.
Exactly. Projects like the EU's Holography for Future Media initiative are working on making this a reality.
But, it makes you wonder, does that kind of immersive recreation risk turning memory into a spectacle?
That's a good point. We might lose some of the nuance and the context of the original event if it becomes just a visual experience.
Right. Okay, what about quantum memory? Now, that's something I really struggle to wrap my head around.
Quantum memory is really fascinating, but yeah, it's definitely a bit mind-bending. It's based on the idea that photons, those particles of light, can exist in multiple states at once, a concept called superposition.
Right.
And when you combine that with entanglement, where two particles can become linked, even if they're far apart, well, it opens up some wild possibilities for storing and transmitting information.
I've heard it has huge potential for super secure communication.
Yeah, absolutely. And while the application of quantum memory to like long-term data storage is still pretty early stage, the underlying principles suggest that light at the quantum level might allow us to manipulate information in ways that just defy our classical understanding of time and space.
It's like quantum physics keeps showing us that reality is way weirder than we thought.
Definitely. And then there's this whole other area where light is being used to create new kinds of computing systems, photonic neuromorphic computing.
So basically using light to create computer chips that mimic how our brains work.
Exactly. Companies like Light Matter are working on developing these light-based chips that can process information incredibly fast and potentially learn and adapt, similar to how our neurons do.
And some people think these synthetic brains could eventually rival or even surpass human intelligence.
Yeah, it's definitely a fascinating area of research with some pretty mind-blowing potential.
All right, last but not least, there are these solar legacy projects which aim to store information in really, really durable ways.
Yeah, using the power of the sun to create these incredibly long-lasting archives, like the lunar arc, the idea of etching data onto the surface of the moon using lasers. I mean, how cool is that?
It's like trying to create a monument to human knowledge that could potentially last for millions of years.
It's a powerful image, and it really echoes the spirit of those earlier projects like the Voyager Golden Record, that message we sent out into space.
It's this deep human desire to leave a mark, to say, we were here.
Exactly.
Okay, so we've talked about the science, the technology, and the philosophical implications of this whole light, time, and memory thing. But it's also really interesting to look at how these ideas are reflected in our cultures and beliefs.
Oh, yeah, absolutely. Light is a powerful symbol across so many cultures, and it's often associated with memory and the passage of time.
Like fire rituals, The idea of keeping a flame burning continuously has been around for a long time.
Yeah, think about the ancient Greeks, who had these sacred flames that represented the continuity of their communities. And even today, we have eternal flames at memorials, symbolizing enduring remembrance.
And then there are all those lantern festivals around the world. Oban in Japan, Diwali in India, Loy Krathong in Thailand.
They all use light in these beautiful, symbolic ways to honor the past, to remember ancestors, to create a connection between the living and the dead.
And light plays a role in architecture too, right?
Right. Oh, for sure. Think about how light is used in sacred spaces like the stained glass windows in Gothic
They
cathedrals.
weren't just for decoration. They were designed to filter and project sunlight in specific ways, to illuminate biblical stories and create a sense of awe and wonder.
Exactly. And contemporary artists like James Turrell, they use light and space in their installations to create these really powerful experiences, often playing with our perceptions of time and the ephemeral nature of light.
And then there's how some indigenous cultures view light as a connection to their ancestors.
Yeah, like the Maori concept of Te O Marama, the world of light, which is all about knowledge and wisdom passed down through generations. Or how, in some African and diaspora traditions, lighting candles is a way to honor and communicate with ancestors.
It's amazing how these ideas about light and memory show up in so many different cultural contexts.
And then you have the whole phenomenon of digital rebirths, holographic performances of deceased artists or AI avatars designed to mimic loved ones who have passed away.
It's like using technology to create these digital afterlives.
It's really fascinating, and it raises some big questions about the nature of memory and identity in our digital age. Like, are these digital representations really a way to preserve memory, or are they something else entirely?
Right. And how do we ensure that these technologies are used ethically and responsibly?
Big stuff to think about.
And, it feels like literature and art have been wrestling with these themes of light, time, and memory for centuries, long before we had the technology to create these digital rebirths or store information in DNA.
Oh, absolutely. Writers and artists have always been fascinated by memory, how it works, how it shapes us, how it fades, how it can be distorted. And light is often used as a metaphor for memory, for knowledge, for understanding.
Like Proust's famous Madeline moment in Search of Lost Time, where a taste and a scent trigger a flood of memories. Or Virginia Woolf's To the Lighthouse, where the lighthouse beam itself becomes this symbol of both the permanence and the fragility of memory.
Or Borges Funes' The Memorious, which explores the burden of perfect memory, this idea that maybe forgetting is actually essential for our well-being.
And visually, think about how artists have used light to depict memory. The dramatic chiaroscuro of Caravaggio, capturing moments in stark light and shadow. Or Turner's luminous landscapes, which often evoke a sense of nostalgia and the passage of time.
And then you have contemporary artists like Hito Steyerl and Trevor Paglen who use light-based media to explore the illusion of permanence in our digital archives.
And even in poetry, light imagery often pops up when poets are dealing with themes of memory and loss.
Absolutely. It's a powerful way to evoke the feeling of memory, that fleeting, ephemeral quality.
And then there's film and new media, where we're seeing all these explorations of artificial and manipulated memories.
Films like Blade Runner 2049 and Eternal Sunshine of the Spotless Mind, they really make you question the nature of memory and identity in a world where technology can alter our memories.
And then you have artists like Refik Anadol, who's using AI to create these incredible immersive installations that explore collective memory. It's like technology is giving us these whole new ways to engage with the past, but it also raises some big ethical questions.
Yeah, for sure.
And philosophically, this tension between wanting to remember everything and the need to forget, it's really fascinating.
Absolutely. Like Nietzsche's idea that forgetting is essential for creativity and for living a healthy life, or Byung-Chul Han's critique of our timeless time, where we're constantly bombarded with information and never really have the space to process it.
Right. And Borges, in the Book of Sand, explores the idea of an infinite book, a book with no beginning and no end. It's this really interesting metaphor for the overwhelming and ultimately paralyzing nature of trying to remember everything.
And, maybe that's part of the beauty of this whole interconnectedness of light, time, and memory.
Yeah, it's a constant reminder that everything is in flux, that nothing lasts forever, that even the most vivid memories eventually fade.
It's a reminder to be present, to appreciate the moments as they happen, because even as we try to capture them with light and preserve them in our memories, they're always slipping away.
So, Influence Decoders, as we wrap up this deep dive, we hope you found it illuminating or at least thought-provoking. It's been a wild ride, exploring these connections between light, time, and memory, from the vastness of the cosmos to the intricacies of our own brains.
Abs-
And we want to hear from you. What are your thoughts on all this? Does it make you see the world a little differently? Let us know in the comments. And if you enjoyed this deep dive, please like and share it with your friends. And don't forget to follow Decoded Influence for more explorations of the ideas shaping our world.
Thanks for joining us.
Until next time, keep decoding those influences.